part na to. Okay, stop sharing. Share again. I want to share something to you. Kumusta naman ang ano dyan, ang panahon? Malakas ba ang hangin? Window. Okay. I hope nakikita nyo to. Frame section, property modifier. Buti meron akong save na ganito. Okay. Nakikita nyo to, guys?
Yes,
Opo,
sir.
sir.
Okay.
Yes,
Actually, this is by the National Structural Code of the Philippines already, but it's the same concept. Pagka bumalik kayo sa American, sa ACI 318, ito pa din yung makikita nyo naman doon. So parang, I think even in other countries where their building code are reference to the American concrete or the ACI 318 is pare-parehas yan. So kung British code yun, mag-iiba na. Pero since we are copying the American code, then it's the same values. So here, as I've mentioned, there are two components. One is the serviceability state, and the second one is the ultimate state. I mentioned that serviceability state is for checking of deflections and cracks and yung mga ganun. Pag ultimate states, ito yung when we are designing the section, the reinforcement, for example. So here we are going to use the ultimate state. It says here that for columns, it should be, can you guys take down note all of these values para pagdating natin doon sa input mamaya sa Etabs, madadalian kayo kung bakit 0.7, kung bakit 0.35. So you can take a screenshot na lang by your phones. So 0.7 sa column, 0.35 sa beams, 0.7 sa walls, 0.35 kapag ka-crack section. What is this crack and uncrack? Usually we are using the uncrack section, so 0.7 lang tayo dito. Pagdating dito sa reinforced concrete slab, 0.25. So, and you can see here beside of this table, it says here serviceability model for time period, building drift, and dynamic properties. For ultimate state, it's for design. So, okay na tayo dito. Stop sharing. Let me take a screenshot as well. Okay, stop sharing. Balik tayo doon sa ating Etabs model. Window. Okay. So, okay, balikan natin yung beam. Tingnan ko kung sino ang take note, modify show property. I will ask you the values of the modifier, or the value of the modifiers. Okay, let's go with the moment of inertia. Okay. For beams, ang moment of inertia ay by how much? Pag ultimate limit state? Anyone?
0.35.
Good, 0.35. And same here, the moment of inertia for...
excuse me, hindi namin nakikita yung ano,
yung Etabs?
nakikita lang namin is yung model, hindi na namin nakikita yung ano, yung
yung mismong box? Wala na?
yung box, wala, hindi.
Kanina meron?
Wala rin. Ano mo na lang yung share na yung whole desktop
Window?
mo. Oo, yung desktop mo na lang.
Okay. Dapat kanina, sinabi mo nyo pa kanina kasi hindi nyo pala nakikita yung it's good na mention nyo na. So stop sharing. Meet your entire screen o window. Kapag yung entire screen kasi lahat okay. Sige na nga lang. Tanggalin ko na tong ano. Ayan. Okay na ba?
Wala pang na-share.
Share your entire screen. Ayan. Buong-buo na yan. Okay na?
Yes, sir.
Yung Google Meet lang ang na-share mo, sir.
Ayan. Okay na siya.
Okay, sir.
Okay, sige, sige. So, let's go to the definition of materials. You go to the define. I hope hindi nyo nakalimutan to. Define materials. Then you go to section properties on the second ano tawag nito? Drop-down list. Okay, and then you go to the frame sections. From that, you will find here the different elements that you created before. Pero hindi na ito yung ginawa nating model last time. But still, you can work on with your models. It's the same. So let's say, for example, we created a certain type of beams. I don't know kung ano yung beam size na na-create natin before, but you can open the beam section. And then you go to modify show property here. Okay, click this icon. And then after that, you will find here the modify show modifiers. Modify / show modifiers. Click that icon. By default, as I've said, all of these numbers are set to 1. But then by following the ACI 318 or the NSCP, we are going to modify the values according to the values provided by the code, which is this one, the serviceability state and the ultimate state. Here we can find that beams has 0.35 of moment of inertia, IG, moment of inertia. I hope you know that, moment of inertia. Okay, so moment of inertia for two axes should be set to 0.35, right? And by practice, we want to avoid torsion, okay? We want to avoid torsion on beams. That's why we always set it to 0 or 0.01 to avoid torsion, okay? So after that, after all this input, then you can click OK. And then OK. Now for the columns, same process. Okay, modify lang natin. Modify show property. If you notice, tong name ng column ko is column 35 by 35, 12 diameter 16. That's how I name column para madali pagdating sa detailing. Okay, or so that I can recognize easily kung anong bakal yung nilagay ko doon. So pwede nyo kopyahin kung paano ako mag-name ng column. The first one is the size, C35 by 35, 350 by 350, and 12 diameter 16 means that there are 12 diameter 16 longitudinal bars. Okay, so let's modify this column. Modify show property. From here, you go here on this tab. Okay, modify show property. So let's go back doon sa NSCP. Here we have columns. This part here. Yes. You can see that it's 0.7. Okay, so let's put here 0.7, 0.7, and 0.7. Ano bang sinasabi doon? Columns are 0.7 of IG. Okay, that's it. 0.7, 0.7. For torsional constant, let's put it 1, 0.7, 0.7. I don't know if we are going to modify as well this upper values here, but it says 0.7 for the moment of inertia, so that should be okay. Click OK for now. Click OK, and OK, and click OK. All right. So after that, anong next? We don't have walls since we don't have wall in the model, but you have wall in your model. Yes. If you are opening your model now, you have walls. The previous model that we did last time. Tama ba? Sir Renato?
I think wall lang yun sa ano, yung sa gitna, yung para sa elevator.
Yes. Okay, let's do the slab now. Define section properties, you go to slab. So dito nyo makikita yung slab, ha? Section properties and then slab. And then from that, you go to slab. Where's the modifier? Here. You can see here the modifiers. Modify show property. So itong slab ko is na-modify na siya, which is correct. 0.35, 0.35, and 0.35 for bending. Okay. Why bending? Slabs 0.35 of IG, of the moment of inertia. What's the formula for bending again? MC over I. Bending moment is stress equals MC over by I. So stress is directly proportional to the moment of inertia. Moment is directly proportional to the moment of inertia, correct? Bending is directly proportional to the moment of inertia. That's why we have to apply the moment of inertia on bending. You can see here 0.35, 0.35, 0.35 on 1, 2, 2, and M12 directions. What is this M11 direction? This is along, if you are looking at the, let's say, the X and Y axis or the local axis, along X, this is what we call the bending M11. Okay? Yung kumbaga, mamaya I will demonstrate to you what is this M11 and M12. M12 is a combination of this, like torsion. Okay, click OK, and then OK, and we're done. Okay. Ito lang medyo hindi ako sigurado dito sa may bandang column. Modify show property. Let me double check it later on. I think this is 0.7 as well. 0.7 as well, but I'm not sure, but let's make it 1 for the meanwhile. Okay, let's consider the moment of inertia. I will check it and I will inform you later on. Okay, so now we are done. Next is we are going to apply loads. We already defined everything here. Define section properties and all of this. Define. But before we are going to apply loads, let's define first our load patterns. Okay, this is so important, our load patterns. Again, this is already created, but I am going to delete these loads here because this is for another code. It's Euro code, so it's not part of. Okay, so by default, ito yung makikita nyo sa Etabs. Punta kayo dito sa load cases. Okay, medyo nakakalito to kapag especially kapag baguhan kayo, or I mean bago itong software na ginagamit nyo. Nakakalito yung load patterns and load cases. Sometimes you go to load patterns, sometimes napupunta ka dito sa load cases. Ganyan. Pero kapag nagde-define tayo ng load, dito tayo sa load patterns. Okay, load patterns, and then you will find dead as default one. Dead, I explained it to you earlier. It is the weight of the slab beam and other permanent elements that are attached to the buildings. Now we are going to add another load, which is a type of dead load as well, and we call it as dead, or the superimposed dead load. Or sometimes for other designers, they will name it as SDL, superimposed dead load, or sometimes SIDL. So let's make it SIDL. Here on the type of load, you should specify, this is so important, type of loads. Okay, you can click this arrow down here, and then you will find these options. You should select super dead. Okay, which means superimposed dead load. And the self-weight multiplier is 0. Why 0? Kasi it will be part of the loads that are coming from the superimposed dead load will be will be included in the load combinations, okay? Load combinations. Sa load combinations siya magpupunta. Ito kasi by mass. By mass. This dead load will be included by mass. Itong SDED or SIDL, it will be included in your load combination. It's IDL or superimposed dead load. You should select here super dead and 0. Anyway, automatically it gives you 0. And then after that, after you define dito sa taas, go to add new load. Kapag click nyo to, itong part na to, automatically pupunta siya sa baba. But for as long na hindi nyo pa na-click tong OK, hindi nyo siya masasave. So pag di nyo na-click tong OK and you accidentally click cancel, babalik siya sa dati, which is the default one, dead. Siyempre, meron pa tayong ibang klase ng dead loads, ng loads, which is, next one is the live load. Ano naman ang live load? Ang live load is, anyone? I assume that you should know live loads. What is live load?
Moving load, sir.
Moving load is a type of live load, correct? And any other definition?
Not permanent.
Non-permanent loads. Yes, it's not permanent. Correct. Very good. Can you give me an example of live load?
Matao, sir.
Very good. That's the best example of live load, mga tao. Yes. So yan, live load. So ang live load is nakadepende sa type ng occupancy. So for example, sa anong building yung makikita nyo na least yung mga tao na nakatira? Sige nga. Or just hindi least pero hindi siya masyadong mabigat, kumbaga. O sige, baliktarin natin. Anong structure or anong type ng occupancy or any type of structure na nakikita nyo na maraming tao, na maraming live loads? I'll give you options. Commercial or residential?
Commercial.
Commercial. Okay, so say malls. Sa mga malls, matatao yung mga lugar na yon. So, ang live load natin doon is mataas as compared sa residential. Residential, it's around 2.0, something like that. 1.9 to be exact, I think in the National Structural Code of the Philippines. So, we are going to define our live loads here. Live loads, LL, we can say live loads. Then you should also change the type of loads here. The good thing about this Etabs icons is it's arranged. So hindi na kayo malilito. So you should define first dead and then super dead and then you go with live load. And then the multiplier is 0. Then add new load. Then next is, let me see kung anong next dito. Okay, let me discuss this one by one. Ano tong reducible live load? So, there are types of loads na tinatawag nating reducible loads. Pwedeng bawasan. For example, lumagpas siya ng 5 kilopascal, we can reduce that one. But there are some limits. Okay, there are live loads that we cannot reduce. Say, for example, the mechanical equipment or mechanical rooms, mataas ang live load doon. But they cannot be reduced. Okay? But let's say, for example, there are type of loads which exceeds 5 kilopascal, for example, at areas na maraming mga tao, yung mga ganon. But sometimes, it's not, logically, it's not all the time na maraming tao doon. Sometimes, wala sila doon. Sometimes, meron sila doon. So, we can reduce that type of loadings and we can specify that one as reducible live load. But not those live loads, like for example, the mechanical rooms. Kasi under mechanical rooms, you can find their mechanical equipments which are permanent to that particular place. So we can call them reducible live load if it exceeds 5 kilopascal. I'm not sure of that number, but I think that's the maximum, 5 kilopascal. Above that one, we can reduce it for as long as it's following the code. Okay, that's called reducible live load. Here, we don't need all of this now. Let's go directly to ano bang mauna? Wind load ba? O okay, nauuna daw ang seismic load. Okay, seismic. Very interesting. Seismic. Very common. Very common S. We can call it S na lang. Okay? S for seismic. Seismic. Excuse me. Okay. Dito sa seismic loadings, as you notice, for dead, SIDL, and live load, wala kayong nakitang option dito sa auto lateral load. Why? Kasi itong tatlong ito is called the gravity loads. Okay? Take note of that. Baka pa-exam yan ni Sir Renato. Enumerate the type of gravity loads. So you should know that. Pag gravity loads, dead load, superimposed dead load, and live load. Or there are only two, actually, dead load and live load, because superimposed dead load is classified as dead load. So those are called the gravity loads. That's why you cannot see here any option to modify them. But if you go to seismic, you have to specify what kind of lateral loads is this. So there are two types of lateral loads. Marami, pero ay merong pang iba, pero but generally we are considering two in the Philippines. One is the seismic, and two is the wind load. Okay, yun na meron tayo, pero malalakas. Okay, seismic, we should choose here the right code to apply. Since ito nga, we attended with Sir Renato the tawag ng Sir Renato, the release of the new, may tawag siya spectral acceleration. We can call it response spectral accelerations. Pero may tawag pa siyang iba. Parang may nickname sila na binigay. Ano, Sir Renato? Do you still remember the nickname? Parang acronym? Response spectral acceleration. Hindi RSA, hindi. Sige. Anyway, response spectral acceleration, which is the new seismic code that we are going to apply in the Philippines. Okay? Ito ay binigay na, pinublish na ng DOST, and I hope by the next edition of the National Structural Code of the Philippines, it will be incorporated in there. Kasi right now we are using the UBC 97 or the Unified Building Code 97, UBC 97, which is a bit ano na siya, we are a bit behind when it comes to seismic. Kasi mas medyo accurate talaga yung response spectral acceleration, kasi they are really mapping the ground and they are taking into account the movement of the ground actual. Okay? Medyo mahirap yung trabaho na yun, but yes, it's very accurate. And the good thing is we're going to use that that code we are going to apply here in our model, so that you will have an idea how to apply it. Okay, so let's choose, instead of UBC 97, we are going to choose ASCE 710. Okay, ASC. Why ASCE 710? Because that's the reference of the code. Later on, yeah, it's the reference of this code, ASCE 710. Even if this code is going to be specified in the National Structural Code of the Philippines, still you will not find here the NSCP here on the list here. So you have to specify it as coming from the reference code. ASCE 710, new load. Okay. After that, we have to modify this auto lateral load. This is where we're gonna take time, kasi I'm not familiar with the map in the Philippines. Hindi yung mapa. Kabisado natin yung mapa pero I'm not familiar with the properties when it comes to seismic. Okay? So let's dadahan-dahanin natin lahat ng to. So the good thing about Etabs is you can specify all the direction of your seismic by clicking all these icons here. So by default, it's already clicked. Lahat nakaklik na lahat yan. But we have to specify something here, which is very important. The first two important input is the point 2 spectral acceleration, or we call it S sub S. I hope that you already open your National Structural Code of the Philippines. Pinag-aaralan nyo na ba yung NSCP? Hindi pa. Hindi pa?
Parang built-in na sa mga subjects nila sa design.
Oh, sige. Anyway, UBC kasi ang NSCP. So these is the two most important parameters na kailangan yung malaman when it comes to the ASC 710 or the spectral acceleration or the response spectral acceleration. The 0.2 second spectral acceleration, ito yung pang maliit na mabilis, kumbaga 0.2 second spectral accelerations. And this is the 1 second spectral accelerations. Where will you find this data? It's from the DOST. I hope nandito pa siya. Okay. So, ito yon. If you open or if you type here the spectral acceleration DOST, it will give you these values here. This is the parent the directory. I hope pwede ko sigurong i-send ito sa inyo. Kay Sir Renato na lang, ano? Sir Renato, do you have the link so that you can send it to them?
Yes, I also have that.
Okay, so para while doing this, they can also open it in their laptop. Lahat nito, Sir Renato, meron sila.
Yung ano lang, 500 year, so 0.2. Yeah.
So, paano gagawin natin? Stop sharing muna para baka ma-share natin yung ano, yung mga hindi dapat ma-share. Send ko kay Sir Renato. Ay, pwede naman ata doon sa tab ng ano no, ng Meet. Meron ba tayong group chat doon? Ay, oo, tama, pwede. Hey guys, so nakikita nyo na yung ano, yung link na sinend ko sa group chat.
Yes, sir.
Yeah, you can open that one. Okay, and then I'm going to share again. Present now your entire screen. Share. Wait a minute. All right, Facebook, okay, blah, blah, blah. Present now your entire screen. Okay. Kikita nyo na?
Yes, sir.
Okay, open natin
Yes,
yung
sir.
SA01, Spectral Acceleration 01, Philippines 2017. 2017? 2017, 2018. So 2017 pa to ano. Medyo, tingnan nyo, matagal talaga yung pag-map. Maybe they started before pa. Okay, ito yan. Spectral acceleration map of the Philippines, 0.2 seconds at 500-year return period on stiff soil. Okay. Stop. Okay. So, let's find kung saan kayo nakatira ngayon. Saan kayo nakatira ngayon? Daming tubig. Ganito kaganda ang map ng Philippines. Very unique. Hindi lahat ng map ganito. So, sa ano tayo? So, Malate. Maasin. Dito tayo Maasin. Correct? You are living here in Maasin City. So, you guys are so lucky kasi you have the red zone. I'm just kidding. The red zone means mataas ang value ng spectral acceleration, which means mataas ang seismic activity sa lugar nyo. So, nakakaranas ba kayo ng matinding paglindol dyan? Medyo mataas yung zone na meron ang Maasin City. But since this is Maasin City, but you are very near to this contour, you can see this contour, red contour here, which means that you have high value of 0.21. Here, you can find it here, the spectral acceleration, 0.2 of G. So, saan tayo? Let's assume 2 na lang muna, okay? 2. Dito sa banda dito, 2. 2 of G. Spectral acceleration, 2 of G. So take note of that. Spec 1, spec 0.2 pala. Spec 0.2 is equals to 2 of G. This map shows the ground acceleration contours at spectral period 0.2 seconds with 10% probability exceedance in 50 years. So that's the basis of this 0.2 seconds spectral acceleration. 10% probability of exceedance in 50 years. Okay. So let's go back to our model. Here. So you should specify here anong value? Sinong naka-remember ng value? 2.0. Right. So you should specify there 2.0 for the 0.2 second spectral accelerations. Sir Renato?
Yes.
Could you explain to them what is the meaning of at least they should know as well. I think you can have it next time maybe. This 10% probability of exceedance in 50 years, 0.2 seconds. In the future, siguro no, you can include this in their lecture. Kasi yes. Meanwhile, ito yung probability na pwedeng magkaroon ng earthquake within a span of 50 years. But Renato will go into that in more detail maybe in your next lecture. Okay? So yun yung parang reference natin. So let's go back. Here, 2.0 spectral acceleration. And we also have the 1 second spectral acceleration. Ano tong 1 second? Then we go back again to the... I hope hindi kayo nahihilo dito sa screen ko. Pwede palang i-adjust yun. Meet. Not meet. Here. Punta tayo dito sa... I think this is the right one. 0.5. Wala naman tayong 0.5. 0.2. Dito tayo sa 0.2. So 1 seconds tayo, no? 1 seconds. 1 second. Yes, exactly. This is the 1 second spectral acceleration. So tara ulit sa lugar. Maasin City. Maasin City. Okay. Maasin City. Here is Maasin City. Hindi naman pala doon sa mismong lugar na yun yung red kanina Kasi ang Maasin is here. Ano tong part na to, sir, Renato? Still part of Maasin?
That is part of Southern Leyte, but it is in the Pacific area.
But is it
So,
part of Maasin City? No.
no.
Kasi
As
ang contour line nyo na is dito eh. So let's go
Oo.
back. Let's go back para mas accurate yung natin. Let's go back. Baka mali yung kanina. Take note of yung contour line natin. Take note kung anong kulay. Maasin. So you are not at red line. Correct? You are at blue line.
yes, the blue line.
Yeah. It should be blue line. So hindi wala pala kayo sa red. So kayong kabahan. Nasa blue line kayo. So around 1.3. Let's take it 1.3. Maximum. Hindi ko alam kung violet to or blue. 1.3. Let's take it 1.3 muna. Okay? So this is 1.3. And here sa spectral acceleration, 1 second, balik tayo. Parang violet yung kanina, nakita ko. Spectral maasin. Ito. Anong kulay ito? Violet?
Violet.
Sige. Saan dito, Sir Renato? 0.9?
I think 0.9 or 0.8.
Okay, let's take the maximum. 0.9. 0.9. 0.9. Okay. And the long period transition is 8 seconds. That's very common. 8 seconds for the long period transition period. What about site class? What site class do we have in your place? It depends on where the structure is going to be put up. Okay, so normally this range of site class will tell you what is the type of soil na pagtatayuan ng building. Is it rocky? Is it soft, clayey, and all? So you don't have the soil report yet. Okay, you don't have the soil report, so you don't have any idea what type of soil is it. But let me go to the NSCP part. Soil type, I think that's page 238, if I'm correct, 238, page 238, 238. Soil type. Should be soil type. Do you have the National Structural NSCP 2015? Do you have a copy of the NSCP 2015?
Hindi ko sure kung may copy sila, pero I can send them a copy.
Sige. Soil type. Hanapin natin yung soil type. I want you to show the different soil type. Okay, tsagayin natin. Hanap natin yun. Let's start from the beginning. This is the National NSCP 2015. And let's go to...
Nandun yata sa 2-238. So, chapter 2.
2-238. Okay. Correct ka. 2-238. 2-238. Chapter 2, ano? So, wala pa dito. 2-238. Hindi ko kabisado masyado to. 2-238. 2-238. So, yan. Habang hinaharap natin. Nalilito ako dito sa page ng 2-238. Should be 2-238 dito, ano, Sir Renato?
Oo.
Dito. So, medyo malayo-layo pa. Two dash 135, so may pa. Curl natin. 2 dash, yun, lumagpas tayo. Yun, 238. Ito na yun, Sir Renato.
Wait.
Wala naman dito. Medyo... Sa ano yun eh?
Sa chapter 3 yata sa earthwork, tama ba?
Ano na to eh? Type of system na to eh. Type of system. Sa bandang unahan yon. After ng wind load. I think after ng wind load. After ng wind load. Anyone from the group who can give me the page of the soil type according to the according to NSCP? Makakabisado niyo yung mga ano diyan, i-design na. Pasensya na kasi matagal ko nang hindi nagagamit ng NSCP. Anyway, okay. So, later on, ganito na lang ang gawin natin. I will explain to you what is A, B, C, D, E, F type of soils. Okay? We can use the internet. Okay. Type of soil. Type of soil structural design. Images. Wala pa din. Hindi rin to. Type of soil, NSCP. National Structural Code of the Philippines. Yun. Soil profile type. Hindi rin to. Hindi rin to. National Structural Code of the Philippines. Wala pa din. Soil profile type A, B, C, D, E. Technical dynamic response spectrum. So Renato, let me just confirm. Ang type A, B is more of rocks, correct? And then as you go down, it will become softer. I mean, the soil properties will be soft.
From the the strongest rock
The
type.
strongest is, yeah, A.
Yeah.
And then, so, okay. And then, by that, you should, whenever you are designing, you should ask the soil investigation results from the geotechnical engineer or whoever conducted the soil report or the soil investigation. You should get a copy of that, and from there it is specified what type of site class you have in your analysis. So for example, ang binigay sa inyo is type B, which is a bit more of rock. So you can say type B. So for now, we can assume site class of type B. Okay, type B. And then we already specified the two most important part, which is the spectral acceleration for 0.2 seconds and for 1 seconds. That's so important. Pag okay na yan, pagtapos nyo yan, and then you go here, it's click. All of these icons are click, which means that you will have all the directions of possible directions of your seismic activity, seismic effect, for example. Dito tayo sa response modification factor, response modifications. This is important as well. Saan yung makukuha tong value na to? It's from the ASCE, and it depends on the type of structure that you are designing. Okay, if it's MRF or moment resisting frames, or I should show you this. It's from ASCE. Let me open the ASCE. ASCE, okay. Dito tayo sa, I think dito. Engineering files, PICE 35. No. Seminar presentation, codes and videos, ASCE 710. So this is the ASCE 710. You can have a copy of this. It's available on the internet. Control find. This is structural system. So tsaga-tsaga lang guys ha. Sensya na. Structural system limitations. This is design coefficient factor for seismic force resisting frames. I think this is the one we're looking for. Let me double check kung ito nga yan. Design coefficient factors for moment resisting frames. So looks like this is for seismic force resisting frames. Okay. So ito yung hinahanap natin. And as I've said earlier, it depends on the type of or type of system na gagamitin. So these are the type of systems na meron tayo pagdating sa pagde-design. Okay, medyo complicated kasi you should know what type of system you are using. For example, in the Philippines, for example, in our model, this is moment resisting frame and it's concrete. So wala tayong walls doon. So which means, ang ibig sabihin nun is yung lateral force natin that is coming from the wind load and earthquake load ay nire-resist mismo ng ating structural elements. Okay? Ang ibig sabihin nun, hindi tayo nagre-release ng mga beams. Okay? Dito, it's highlighted already, ordinary reinforced concrete moment frames. So this is the type of system that we used in our model, moment resisting frame systems, MRF. Later on, makakabisado nyo itong mga different type of system dito. Magiging familiar kayo dito when you go for structural design. Okay, so ang very common is the moment resisting frame. Here, you will find different values of, say, R, or the response modification coefficient. Or in other codes, we call this one as, I think sa Eurocode is, we called it as the behavior factor. Okay, the behavior factor. So, ang ibig sabihin kasi nito is, parang ang ibig sabihin nito is gaano ba how can I say this? there is what we call dissipation kung paano ba mag-absorb ng forces yung ating buildings, yung ating structural elements, at paano yung behavior niya when it comes to releasing these forces. So ang danger kasi is yung mga element natin na brittle, or let's say for example masyadong stiff yung ating building, yung ating elements. Pag stiff siya, pag once na nag-absorb yan ng energy from earthquake, is hindi niya ma-release. So pag hindi na-release yung force na yon, ang tendency is doon magko-collapse yung ating structure, yung ating elements. So the stiffer the building, or pagka mas masyadong stiff siya, mas malaki yung kanyang force na ina-absorb. Okay? Whereas kapag ductile yung ating elements, which means na kaya niyang mag-release ng forces, kaya niyang mag-release ng energy after such events of earthquakes, for example, mas okay. Kaya ito yung tinatawag nating response modification coefficient, or we can call it as the behavior factor in other codes. Okay? These values are ranges from, I think you have here, the minimum is 3, and the minimum is actually, this is from 1.5 to 8 as far as I know, from 1.5 to 8. The maximum is 8, and the minimum is 1.5, right? And we are going to use 3. Okay, 3. Ano pang dapat na i-explain dito? Dito, sa deflection amplification factor, these value here, we're going to use it later on when we want to convert the elastic deflection to inelastic deflection. Okay? But for now, huwag kalimutan nyo muna yan. So, ang kailangan lang natin is itong response modification coefficient, or the 3. Let's go back to our Etabs. You should specify here response modification factor of 3. And kailangan pala yung system over strength. You should also need the over strength factor, which is also 3. Okay, take note of this value here, 3. And deflection amplification, gaya ng sabi ko kanina, kailangan din pala, you should also need this 2.5 here, deflection amplification factor of 2.5. So you specify here deflection amplification factor of 2.5. So 3, 2.5, and importance factor of 1. Let me double check. Bakit mababa yung values na yan? I think we have the correct inputs. Okay, so pagtapos na yan, na-input nyo na yung different properties na yon, then we are done. Mahirap ba? Mahirap ba yung pag-define ng seismic? Hindi naman.
Yes.
Madali lang yan kapag paulit-ulit na ginagawa na.
Yes, sir.
Especially kapag actually yung ating National Structural Code of the Philippines, ang maganda dyan is kapag na-incorporate na nila tong mga values na to, especially the 0.2, 0.9, or 0.2, 1 second spectral acceleration, hindi na kayo mahihirapan. Sundan nyo na lang siya. Step by step yung ginagawa doon. Especially doon sa UBC 97, yun kasi yung, I work in the Philippines for 2 years. So, nag-practice din ako dyan ng 2 years. So, ang ginagamit namin noon is, of course, the UBC 97 pa. But that was 8 years ago. So, medyo hindi ko na kabisado. Anyways, so alam nyo na ngayon kung paano gamitin yung spectral acceleration. You have the map from the OST. And then from that, you would input this according to the location of the project that you are going to design. And then you should have a report from the geotechnical engineer. And then from there, you should specify what type of soil is your project. And then from that, click OK. Now we are done with the seismic. Let's go with the wind load. Wind load. From here, you have to select wind, and here you have to select wind load ASCE 705, ASCE 710. Just to be consistent, choose ASCE 710. Okay, and add new load. And let's modify this wind load here. Gaano ba kalakas ang typhoon sa Maasin? Any idea? Any idea kung gaano kalakas ang typhoon sa Maasin?
No, sure, no. No, sir.
Ano? Let's go to NSCP. And let's go to, I think, page 92. Page 92. Page 92. Let's go here, page 92. Yes, exactly. Oh, so yung kanina pala is 238. This is the soil type. Zero na to. This is the soil type kanina, yung 238, which is correct from hard rock to soft soil. So ito yung sinasabi ko kanina na A, B, C, D, E. Ito yung different properties ng soil on the top 30-meter layer of the soil. Okay? So these are the different properties from rock to soft soil. And in our analysis, we assume rock since we don't have report from the geotechnical yet. So most probably you're going to use this as B. But it depends kasi there are many locations in the Philippines where the soil is not good, not stable. Medyo may pagka
I think in our place, it is SD.
SD, stiff soil. Sure.
Marami, madalas mag-landslide dun eh.
I see. So, but still it depends on the geotechnical report, okay? You have to base from that. But since you mentioned about SD, we can change it now. Seismic, modify. Should be D, yeah? D. Site class is D.
Oo, report yan sa from DPWH.
Oh, I see. So medyo ano pala no? Hindi medyo challenging pala yung pagtatayuan ng structure sa inyo. Anyways, let's go to the wind load. Guys, if you haven't clicked OK yet, might as well better if you click OK na. Kasi kapag once na you click cancel, all of these inputs that you've made here will be mabubura siya, hindi mo siya masasave. So, kapag to be on the safe side, kapag marami na kayong dinefine dito, you can click OK and go back to this menu. Kasi I click OK now and then I go back, define, load pattern, and then I can modify this wind load. Okay. So here, we are going to define the wind. What about wind load, Sir Renato? Any idea kung ano ang speed natin sa lugar na?
Nasa zone 4 kami, so 250 kilometers per hour.
Zone 4. Zone 4. Zone 4. This is page 92. Maybe. Zone 4. Tingnan natin ang lugar. Iwan niyo ako . Saan ba yung maasim?
Dyan 290 yata.
Ito, range from 280 to 290. Ano? Ito yung lugar nyo, no, sir?
Sa baba.
Hindi ako.
Yung
Dito.
say 290 to 300. Yung 290 to 300.
Ito?
Sa gitna dyan, baba konti.
Ito?
Yan.
Okay. So, 295. Mga ganon. 295.
Yes.
Kilometer per hour ba to? kph?
KPH.
kph. So, we need to convert to mph. Convert natin sa mph. Anong equivalent nun? Can you convert? This is
183.
183. Okay,
Yes.
let's make it 185. So 185 miles per hour. Exposure type. Okay. So this is exposure type C. So it depends on the exposure type pa. Ano kaya yung exposure type natin dyan, sir? I think we only have one exposure type, yeah? Type C. Values are nominal design, 3-second gust wind speed in kilometers per hour at 10 meter above ground. Exposure C category. We do have one exposure type. Yes. So type C. Okay. And then the topographical factor KZT is, you can have it 1. Okay, 1. And then the gust factor is 0.85. Directionality factor is 0.85 as well. You choose your top story. Ito yung pinaka-top ng story nyo. Okay, and then let's say for example, what about if I have basement? What will be my bottom story? Any guess? Let's say I have 3 basements. What should be the bottom story? No. What do you mean by 6? Ganito. Pag nagseset ka ng bottom story, it should be the story na naka-level sa ground. Okay? So any floor or any story below the ground level, hindi na siya kasali sa analysis ng wind load. Okay? Well, it does make sense kasi yung hangin is ina-absorb lang nung mga floors above ground level. Okay? So since we started from the base and we don't have any basement, we can set the bottom story as base. And if you have parapet on top of your building, say for example sa rooftop is meron kayong parapet na 1.3 meters or 1.5 meters, then you have to specify as well. I think we are now okay with this values. So okay na tayo dito. What does it mean by exposure from extents of diaphragms? Which means na yung lateral loads natin is may diaphragms. Okay? Diaphragms. Kasi mag-specify tayo mamaya ng diaphragms. I think we already specified in our previous model the diaphragms, rigid and non-rigid. So after that, kapag okay na to, click OK. Now we are done with all the type of loads. Question. Any question from the group? Wala naman.
Wala naman. Anyone? Next questions or clarifications?
Baka may mga naguguluhan ka dyan kasi medyo mahirap naman ito, especially for you. Naiintindihan ko kasi when I was at your when I was in my 5th year na sila, no, Sir Renato?
3rd year. 4 years na lang yung ano ngayon.
4 years na lang? Galing. Kasi yung sa amin before is 5 years. So when I was in my fifth year, I was focusing more on my subjects than on the codes or national structural codes. So, hindi ko masyadong kabisado ang NSCP during that time. So, naiintindihan ko yan.
Naka-record naman, sir.
Ha?
Oh, naka-record na yung, sir Maglasang, naka-record naman yung,
Itong ating class, you mean?
sir.
I think no.
Sir Maglasang, sir.
I think si Ivy yung pinakasan ko.
Okay. So, na-record pala tayo, ano? So, ayan. Kapag okay na lahat ng loads, then, anong next na gagawin? We are going to apply now the different type of loads on our structure. So, let's go to story 1, close, for example. Okay, let's focus first on the first part, which is the superimposed dead load. The dead load, we don't mind about it kasi mismo yung ating elements is yun ang tinatawag nating dead load. So we don't need to apply dead load anymore because that's part of the structure permanent. We go on with the superimposed dead load. What are the different types of superimposed dead loads? Ito yung architectural finishing, mechanical ducting, sealing, movable partitions, and of course, if you have like residential building, it's very common. The CHB or the hollow blocks, it's part of the superimposed dead loads. Okay. Now, different type of loads. I should show you where are we going to get these type of loads from the NSCP. Okay. So this is the list of material densities that you are going to use whenever you are going to define your superimposed dead loads. Right? Andito yung mga different properties. You should use this. Okay, important part, I want to explain one important part, concrete masonry units. Okay, this is so important. Usually, dito nakadepende yung ating CHB, which is mataas kasi yung load ng from CHB. So, you should be careful as well how to calculate them. Let's say, for example, your CHB has a density of 16.5 kilonewton per cubic meter. And then you have here 800 spacing grout, 800, 600, 400, and full. Sometimes we do choose 800, sometimes 600. So depende sa gagamitin nyo. Sometimes no grout. It says here, hollow concrete masonry units, unplastered, 0.24 kilopascal for each face plastered. What does it mean? So whatever load that you computed from here, you should add 0.24 kilopascal on both sides for plastering. Okay. Let us say that we are using the 150. Ano bang very common sa Pilipinas na CHB size? Is it a 150 or 200 thickness?
I think 150.
Okay, 150. Let's use 1.53. This is the density. Take note that this is 1.53 kilopascal. So 16.5 kilonewton density unit. This is 1.53. So from 1.53, you should add additional We can say from bottom to top of the building. Ang unit natin doon is kilopascal. How is it going to be applied? So, ang gagawin mo is, since it's kilopascal, you have to multiply it by the height of the building, height of the floor. Para maging, after that, it becomes kilonewton per meter. Okay? Kilonewton per meter, it will act as a linear load that is acting on the beam. Say we already have 2.01 kilopascal. So you go to edit story data, or you know it by yourself, the floor height of the building. Here, for example, I have 3.83 meter. I don't know why 3.83 meter. But ano yung floor na in-assume natin before sa model nyo? Edit story. Sir Renato, I think this is 3.3. Yung in-assume natin. 3.3.
Parang 3.3 or 3.
3.3. Refresh through, click OK, and OK. So, okay. We assume 3.3. So, from that, from your, saan ba yan? From the National Structural Code of the Philippines, 2.01 kilopascal. Okay? 2.01. Pwede lang ba akong magkano dito? Wait a minute. Anong oras na dyan? Pilipinas.
2 minutes to 5. 5 na.
Walang ano, hindi malakas yung hangin. Hindi naman.
Hanggang may
Di ba may bagyo sa Pilipinas, sa atin?
Umakyat yung bagyo papunta sa Sorsogon.
Kala ko pumunta sa Isabela. Huwag mo na mapakyatin.
Doon siya mag-stay, pre.
Saan? Sa
Isabela for a couple of days.
Baka ano siya.
Mag-stagnant doon kasi may high pressure sa taas.
Baka may dadaanan lang siya doon. Tapos pupunta. Hindi, pataasin natin, pupuntahin natin sa Taiwan. Okay. So, bakit hindi siya, wait a minute lang, ha? Wacom. Saglit lang guys, ha? Pasensya na. Mapping. Scroll ko sa mapping pen. Mapping. Scheme area. Full. Default. Okay na. So, ang page natin kanina doon, this is for live loads na. Ito yun. So, ito yung dinidiscuss ko kanina. We choose this 150 na na thickness ng ating CHB, and I choose this 800 para hindi kayo malito. And from here, I have 1.53 kilopascal. So, 1.53 kilopascal, okay? 1.53 kilopascal plus, meron pa tayo dito na 0.24 kilopascal here, 0.24 kilopascal. Okay? And take note that there are two sides na ipla-plaster natin. So, all in all, magiging 2.01 kilopascal. Or this is kilonewton per meter squared. Take note, this is 2.01 kilonewton per meter squared. But we know that the height of our building is per floor 3.3 meter. So to be able to get the loads, say for example, meron tayong dalawang beam. Okay? Simply supported, for example, but it's not simply supported. We are going to get this intensity here, W. How are we going to get that one? We simply multiply 2.01 kilonewton per meter squared by our height. Kasi yan yung yung height ng CHP. Okay. Now this value here, take note, this value, this 3.3, to. Sometimes hindi siya 3.3 kasi we need to deduct the height of the what? Height of the beam. Let's say for example, yung beam natin is 400, tama? 400 mm yung beam natin, di ba? In exact calculation, which I usually do, ang ginagawa ko is exact calculation. Hindi siya 3.3. It should be multiplied by the height of the floor minus the height of the beam. Kasi half of the beam, not half of the beam actually, it's from the level of the structural level to top of the beam. So you should deduct the entire height of the beam. Tama? 0.4. 400 mm is 0.4 meter. 0.4? 400 mm? Is it correct? So yan ano? 300. 3,300 plus. So 2.9 na lang. Kinalky talaga. Okay. Yan. So makaka-relate kayo in the future kung bakit kayo gumagamit ng calculator. Most of the time, kahit pwede nang gamitin ang utak, gumagamit pa rin ng calculator. 5 point. What's this value? Any idea? 5.829 kilonewton per meter. Okay. That's for the perimeter columns. What about, let's say for example, ang ating CHB ay hindi nakapatong sa beam. Say sa loob, syempre meron pa tayong ano doon, di ba? May mga CHB pa tayo doon sa loob, di ba? Sa loob ng ating sa mga kwarto, for example. So, pag doon sa loob naman, ang gagawin natin is 2.01 multiply by, hindi mo na siya babawasan ng beam height. So, automatically 3.3 na. Mas mabigat. 2.01 less 3.3. 2.01 multiplied by 3.3. These values is 6.63. 6.63 kilonewton per meter. Okay. Yes. But sometimes kasi there are some part of the loads na ina-apply na natin siya as area. Kumbaga area na siya, by area ang gagamitin natin. But this time we're going to apply it on the beams, for example 5.82. So let's apply now. What you do is kapag you have typical stories for us, for example, we have typical stories, just click this icon here and set it to all stories na lang. Okay? And then from there, you don't mind about do we need to, you can turn off all the columns para hindi siya ma-select. Kasi last time, I did one weird na nangyari sa Etabs. I applied loads on beams, and what happened was it's also applied on columns, and it becomes linearly distributed pababa, which is hindi ko pa na-experience yun before. Just to be on the safe side, you can turn off all the columns. From here, you should know this check icon here. Click this one here, and then unclick columns, and the column should disappear in the plan. After that, since we set the model to all stories, we can select all the perimeter beams here. Okay, kapag na-select na window nyo na lahat ng beams sa perimeter, then you go to assign. Okay, take note of this. This is important. And you go to frame loads, and you go to distributed. Okay, click this, and you will find this window. Then you set your loads to superimpose dead load. So important. Not dead load, not wind load, but superimpose dead load. Okay. From there, you have to specify this value over here. What does these trapezoidal loads means? If you have like trapezoidal loadings, you know what a trapezoidal loading is. One part of the beam is higher, has a higher intensity. Let's say from the start of the beam, you have higher intensity. Then it goes down to linearly decreasing load until on the other part of the load. It's called trapezoidal loads. But we are using here uniformly distributed loads. Value 5.829. You can assume 5.85. Okay, 829. 5.85. Or you can say 5.9. Pwede kayong mag-round up. Depends on you. 5.9 for example. Then, after that, click. Pwede nang apply. If you turn on your 3D model, you can find here the loads. Ito yung para sa CHP natin. Okay? Wala naman kasi tayong architectural plan. So, when you are doing the real design, for example, you have the architectural plan. You will find here that the different locations of the walls you can apply. Okay, you can apply the loads. But we assume na yung CHB natin is nasa perimeter lang. Okay, and for that, if you notice, nag-apply ako ng loads dito sa taas sa rooftop, which is not hindi tama. Tama? So, kapag hindi tama, palitan natin. Paano natin siya papalitan? Hindi ko na nakikita yung icon na yan. Okay, we go to plan. Plan, palitan natin siya. We should nawawala yung icon na all stories. Nawawala yung icon na all stories. Let's save this. Minsan, ganito talagang Etabs. Naka-all stories na siya. This is the unit. Nandito lang yun eh. 3D. Anyways, let's close this for a while. And then let's open again. 2013 and 16. Yan, pag hindi kayo mahanap na icon, naka-hide or something, kasi sometimes ang mga software may mga, especially safe, maraming bugs doon. So, ang ginagawa natin is close natin and then we open it again. This icon, I was looking for this icon here. This is, I should set it to one story only. Let's see if the load is still there. Display, loads assign, frame, instead. Yeah, naran pa din. Doon yung loads natin. So we want to update these loads here. It's not 5.9, but it's the height of the parapet wall. If you notice, if you still remember, we assume 1.5 height of your parapet wall on top floor or on rooftop. So that 1.5 should be multiplied by the density of the hollow blocks. The density of the hollow blocks that we use is 2.01 kilopascal multiplied by height. So this is for the parapet wall. So meron tayong 2.01 multiplied by, this is for the parapet. How much is it? 2 times 1, 3.5. Tama? No, 2 multiplied by 1.5, 3. Simple arithmetic. Nawawala tayo. So 3 kilonewton per meter. So this is for the parapet wall. All right. So punta natin si plan. All right. Okay. We should press this. Yeah. Okay, guys. Pag nawawala yung 1 story, 2 story, or any icon here, the best thing is not to close your model, but just click this refresh icon here. This is like a refresh icon. Once na press nyo to, babalik siya sa default. Okay, papakita yung mga icon na nawawala. So we are now on story 1, but we should go on the last story 3. And then we should select all of this beam here and apply 3 kilonewton, assign frame loads distributed, and we should apply SIDL of 3 kilonewton per meter. All right, and then apply. And then we want to look at the 3D model. Medyo pangit yung 3D model natin. Let's go on the section properties. Pa din, material. Okay, section properties. Doesn't matter. So that's our hollow blocks. Now we want to apply superimposed dead load that is coming from the movable partition. So paano pag may mga movable partition tayo sa loob? Let's say for example, ang perimeter natin is CHB and we want our building to be carrying light loads. So what we are going to apply is the movable partitions na tinatawag. How to get the value of the movable partition? It's also in the National Structural Code of the Philippines. You should find it here. Frame walls, exterior stud walls, exterior stud wall with brick veneer, yung mga ganitong mga more on frame partitions here. You can find here the movable partitions 0.24 kilopascal, steel 0.19, wood studs 0.38, unplastered wood studs. But usually kasi ang weight ng movable partition, yung total package na siya is around 1 kilopascal. 1 kilopascal for movable partitions. And then from 1 kilopascal, yes, we assume the movable partition to be 1 kilopascal. Say, saan tayo pwedeng mag-scratch? Nakikita niyo yung screen ko ngayon?
Yes, sir.
Anyone? So let's say that the movable partition is, we assume to be 0.97, 0.1 movable partition. Saan tayo pwedeng mag-sulat? So, movable partition, for example, is 1 kilopascal. And then we also have here the floor finishing, floor fill, ceilings, floor fill. Usually, ni-specify kasi ito ng architectural, ng architect, yung yung klase ng tiles na gagamitin, gaano kakapal yung ating floor finishing, yung mga yon. And then from that, you have the different density of the materials and then you will multiply it. So kailangan ang makikita mo ang i-apply mo na load sa slab mo is this movable partition, plus you should have here the floor finishing. When I say floor finishing, kasali na dyan yung mga tiles and all. And then you should also have your ceiling. Pag sinabing ceiling, nandyan yung mga mechanical ducting, mga ganon. Okay? Ceiling. So all in all, usually nagre-range to ng 2.5 normal. 2.5 kilopascal kilonewton per square meter. Okay? So may values kayo na ilalagay dito depende sa section na ibibigay ni architect na makikita nyo later on in your design. This floor finishing will include the type of tiles na gagamitin and the thickness of the finishing on floor. Actually, dito siya makikita. So whatever thickness na makikita nyo doon, cement finish, 25 mm on stone concrete fill. For example, you have 1.53 dito. And then say, ito yung ginamit mo, 1.53. Then you should put here 1.53. 1.53 for example. Example lang ha. And then sa ceiling for example is ceilings point you assume 0.5 or 0.48. Saan ba yung ano natin? 0.48. You assume 0.48 here. So ito yung gagawin nyo later on pag nagde-design na kayo. All in all, pag in-add nyo yan, 1 plus 1.53 plus 0.48, ang total yan is 3.01. Mataas ang loading. This is approximately 3 kilopascal. But we will assume 2.5 kilopascal. Okay, masyadong mataas yung 3 kilopascal. Kasi depende yan. Depende sa combination na ibibigay ni architect later on and of course ni mechanical engineer ko na yung gagamitin. Alright? Okay ba? Naintindihan ba tong part na to? Any response from the group? So this is 2.5. Ito yung ginagamit ko kasi pag nagde-design ako, 2.5 kilonewton. These will take into account the movable loads, the finishing, and the ceiling, 2.5 kilopascal. So it depends. For example, nagde-design kayo ng residential, this is applicable, 2.5 kilopascal. But for commercial buildings, it will vary. Bakit? Kasi sometimes in commercial buildings, mas mabibigat yung ating mga ducting doon. Mechanical, from mechanical equipments. From mechanical layouts, for example. And then, yes. So, magbabago tong value na to. Meanwhile, this is the type of loads, superimposed dead loads that I will apply on slab. Okay? So, kapag meron ka na nitong 2.5 kilopascal, you go on plan. You should choose this. And then, pwede mong i-apply sa lahat. Need to apply all. Kasi sa taas is meron tayong waterproofing ng rain. Sa taas. Anyways, we don't consider the waterproofing muna. Kasi another loads yun eh. So waterproofing. So from story 1 to story 1, you have that load will be applied on story 1 and story 2, but not on story 3 kasi sa story 3 wala namang movable partition doon. It's rooftop na. So you select all. Sorry. You select all. Anong nangyari na? Nawala na siya sa linya. Oh, nawala siya sa linya. Yan niya. Dapat pag ayaw niyang pumasok. Okay, ayaw niyang pumasok. So, we select the slab and then we apply the type of loads, assign. Kanina, frame loads yung ginamit natin. Yun naman, shell loads. Shell loads and then go to uniform. And then from there, you have to choose here the SIDL or the superimposed dead loads. So as I've said, I have the intensity of 2.5 kilopascal, which takes into account the loads that are coming from ceiling, from floor finishing, and from the movable partitions. Okay, then click apply. All right, there you have it, 2.5 kilopascal. 2.5 kilopascal. Okay, sige na. 2.5 kilopascal. So from that, you have to move on the second floor and then you do the same. Click all the slab and assign shell loads, uniform, and you put here 2.5 kilopascal as well, right? And then you go upper floor by this arrow here, move up. This is the rooftop, I guess. Yes, the rooftop. So we don't need to apply partitions loads. So dito is not 2.5. So we should deduct 1 for partitions because we consider that the partition have 1.0 kilopascal intensity. So we should only need here the ceiling below this slab and of course the finishing. Sometimes we need sometimes we need to consider the waterproofing membrane, which has some loads as well, equivalent loads. So you should consider here as well. Meanwhile, we're going to apply 2.5 less 1, so that's 1.5 kilopascal. Sign, shell load, uniform is ideal. This is 1.5 kilopascal. But then again, this is not. This is just an example, okay? So be careful when you are doing your design. You should be very specific of the different materials that you are going to use, since we are just demonstrating on how to apply loads and how to consider the loads with respect to the different type of loadings. Okay? So, tapos na tayo sa superimposed dead load. Okay na tayo sa superimposed dead load. Now, let's go to live loads. So, ito lang naman yung medyo matrabaho. Dead loads and live loads. Or superimposed dead loads and live loads. Now, I want you to be familiar. Sir Renato, still there?
Yes.
What time are we going to finish this?
Maybe 30 minutes more.
13 minutes more. So, paspasan natin. Ito sa live load tayo. So, let's go back to the codes. Yes. Let's go to live loads. Ang live load is nasa, I guess, on the next part of this page. Yes. Sorry. Inom muna. On this page of the NSCP, we have the minimum uniform and concentrated live loads. Uniform load here on the third column. You will find the uniform load here on the third column. So sa plano, especially if you are dealing with commercial plants, commercial buildings, not all the floor will have the same type of loading. Sometimes meron tayong tinatawag na hallway, which means na mataas yung loadings doon. Sometimes meron tayong mga hotels wherein parang residential lang din yun kung i-consider in rooms, sa mga rooms lang. Pero pagdating sa hallway, we will consider higher loadings. Like for example here is schools. Schools, ang classroom is 1.9. Yung corridor niya above ground floor, which means yung second floor, is 3.8. And then the ground floor will be 4.8. Another example, storage rooms. Pag storage rooms, mataas yun. Ang kinoconsider natin is 6 kilopascal and 12 kilopascal. Pagdating sa mga malls, you will find stores in there. Retail and wholesale. Sa retail, 4.8. Wholesale, 6.0. Maraming stocks doon sa wholesale. So, mas mataas yung loadings natin. And for example, office. Yung mga offices na nakikita nyo, yung mga call center and other offices, let's say for example, they have 3 kilopascal. Kasi may mga computers doon sa mga offices. And most importantly, we are later on residential. We will end up with the residential. Ano pa ba ang kailangan nating malaman dito? Hospitals is also important. Kapag ganun pa din, corridors above ground floor, 3.8. I think it's the same as school. If you go dito sa school, yes, corridors above ground floor, it's 3.8 kilopascal. And yeah, parang parehas sila ng hospital. Office, this is for this is a commercial Commercial, hospital, libraries. Okay, let's go to our part, which is residential building. So ang basic floor area, we have 2.0 kilopascal. Usually, for us, practicing designers, yung mga nag-work na dito, ang practice kasi namin, when I was in Saudi Arabia, ang practice namin is we make this as 2.0 kilopascal. So we don't go very specific as 1.9, but we make it 2.0 kilopascal. For exterior balconies, you can use 2.9 or sa practice, ang ginagamit namin is 3 kilopascal. Storage room is 2.0 kilopascal as well. So ito lang yung gagamitin natin, guys. Hindi na tayo magpapakalayo-layo pa. Basic floor area, we will use 1.9 kilopascal. And storage room, we don't have storage room. So ang gagamitin natin, since we have like a very typical building, very typical, kasi napaka-regular din. And at the same time, this is just a demonstration. So we will use, later on, I hope you will understand this concept of applying different live loads. Ang mangyayari kasi, ganito ang mangyayari. Let's say for example lang, ginawang hallway tong part na to ng floor. So you should apply here, assign shell loads. Example lang I will change it later on. Anyway, live load, choose live load. Ginawa ito na hallway, and from the NSCP, kapag hallway, saan ba yung hallway? Access floor, parking garage, dining, hallways, stores, schools, blah, blah, blah. Ano naman? Stores, schools, residential floor, exterior balconies, offices, manufacturing, libraries, hospitals, access floor system. Wala na. Asan ang hallway? Anyway, we considered for residential, for example, exterior balconies, 3 kilopascal. Dapat kasi, especially kapag hotel yung dinidecide mo. Usually sa practice, if you are designing hotels, ang hallways doon is usually nilalagay is 5 kilopascal, okay? Say for example, nandito yung elevator, so meron kang hallway dito to serve the different rooms here. For example lang consider mo na dito. Yan. So, imaginary, imagine that there is an elevator here, okay? And on this elevator, there will be hallways here to serve the different rooms on this hotel. For example, but we are dealing with residential, okay? Let's just imagine that this is a hotel. So ang gagawin is you need to apply here loads of 5 kilopascal. Assign. Dito na tayo kanina. Live load of 5 kilopascal. So there you have it. You have 5 kilopascal here. And since this is room, these are rooms, okay? So you need to select all of this remaining areas, and you need to apply assign shell uniform live load of 2.0 or 1.9 kasi ginagamit, but we apply 2.0 sa practice. Okay? And then you click apply. So you can see that there are different intensities on each part of the floor. We have 5 kilopascal and 2 kilopascal. The challenging part here is when are you going to, or where are you going to apply these loads? Because we don't know exactly the width of the hallway. For example, what if the width of the hallway is not exactly on this part? Okay, anong gagawin mo? Kapag ang hallway mo is like 2.5 or 3 meter width of the center, for example, dito sa gitna. So anong gagawin mo? What we usually do is we create slab here but not anong tawag doon? Non-slab. Draw from here. Okay. Mag-draw ka ngayon ng draw slab on this center here. So let's say for example, I will create 3 meter. For example, 3 meter. So 1.5 offset siya. Right? 1.5 offset from here. But paano ba tayo mag-draw ng slab? 1.5. So this is millimeter, 1,500. Depends on you kung saan kayo nadadalian ng drawing ng slab. Hindi nagpapakita yung center. Snap. Ano tayong snap options? Define. Draw. Snap options. Ito nga pala yung snap option, guys. I wanted them to show you also how to click the snap options. Snap options means yung kung gusto mong magpakita yung middle ng beam, yung end ng beam. Parang AutoCAD. You go here on draw, and then you will find here the snap options. Click this, and you will find the different snap options here. Sometimes nawawala tong line endpoints and midpoints, which is very important. Also the intersection if you want it. This is very useful, and the perpendicular projections. But for now, let's use the line ends and midpoints. Apply. Okay. So that pag mag-draw ako ng slab, for example, and I want it to be this type of slab is called none. Okay? Hindi siya slab. Ipapatong ko lang siya as none just to be able to apply live load. Okay? Wala siyang offset option here. Correct? Wala siyang offset option. So what we are going to do is we create an imaginary or reference beams. Let's use this, for example. We will delete it later on. So it's not a big problem. Choose the center here. Now you see, I can choose the center and it's offsetted by 1,500. You can see naka-offset siya ng 1,500. And then return ako ulit. Naka-offset din siya ng 1,500. Now you will see my reference lines in there. Don't you forget to... Ito yung problema natin ngayon dito sa ano natin. I hope hindi nyo ma-encounter to yung lalabas yung window. Pag just in case ma-encounter nyo to, lumabas yung window. Oh shit. Ay, sorry. Lumiit na siya. So, save. Just save it. Save. And then after that, close and then open it again. Ganyan talaga yan. Open. Okay. Save nyo lang yung model nyo and then open it again. Para babalik siya sa default. Diyan pa ba kayo?
Yes, sir.
Yes, sir naman, sir.
Okay. Okay, very good. So, saan na ba ako? File. Sana okay na. Yes, okay na. Ayan. Bumalik na sa dati. So ngayon, as you notice, nag-draw ako ng reference lines dito. Dalawang line just to be able to capture that part of the hallway na na-occupy dun sa ating building. Okay? So now that I've drawn these two reference lines, what I'm going to do next is to draw this none lines. Okay? Later on, you will know kung bakit ako nagdodraw ng none lines dito. What is none lines? These are hindi siya slab. Kumbaga, floor area lang na ilalagay mo just to be able to put the loads na nandoon. So here, from here, I have, I will select this none lines. I will assign, but wait lang ha. Kapag dinisplay kasi natin yung loads, display loads assign shell, ito yung medyo may encounter nyo na problema, konti. For example, in-applyan ko siya ng 5 kilopascal. Since this hallway here will carry 5 kilopascal, live loads of 5 kilopascal. Apply. Close. Display. Loads assigned. Shell. Live loads. Okay, may 5 kilopascal dito. And at the same time, may 5 kilopascal pa dun sa slab, dun sa loob, which is mali. Mali yung mag-assume tayo ng gano'n. So, anong gagawin natin? Any idea? Kasi may 5 kilopascal pa dito sa loob. Which means kapag inad natin 5 plus 5, 10 kilopascal na yung naka-apply dito sa loob. Usually yung ginagawa namin is sa safe, it's very okay sa safe. Safe is a different software used to design slab. Mas mabilis doon. But here, Etabs is only for the design of columns and beams and walls. So, ang gagawin natin is we usually separate this part of slab over here. Pwede naman yun. Separate natin itong slab dito. And then we will deduct later on. Nakuha? Ganito. For example, this is, we set this muna to 2.5 or 2 kasi yun naman yung loading, shell loads. I hope hindi ka nalilito. Nakakalito yung pagkasabi ko, 2 kilopascal. So, meron na tayong 2 kilopascal sa loob. Ngayon, ang kulang na lang doon sa gitna is ilan? 3, tama? Para pag pinag-add mo yung pag pinag-add mo yung 2 plus 3, that's equal to 5. Shell loads, uniform. Ilagay mo dito is 3, replace, para ma-replace yung 5 kilopascal kanina. Okay, so ganyan yung ginagawa natin para ma-capture natin yung loads ng slab mismo and then yung loads na nilagay natin sa non-slab. So, 3 kilopascal para sa non-slab plus 2 kilopascal para dito sa slab, dito sa main slab natin, that's equal to 5 kilopascal, which means, usually, ito sa natin sa safe, I'm not sure if dito sa Etabs, nagpapakita dapat yung intensity, display, show, loads assigned, shell, it should be intensity. Wala, hindi pinapakita yung intensity. So safe, pinapakita yung intensity dito. Okay na tayo sa live loads. But since this is just an example of the hotel, okay? As I assumed kanina, just to be able for you to show how to apply different intensities of live loads. I hope nakuha nyo yung concept. Okay? For example, kitchen, may nakalagay dito na kitchen sa corner. For example lang dito, then you have to apply the kitchen loads from the National Structural Code, NSCP. Kasi meron tayong dito kitchen, residential printing office, library, hospital, dining rooms and restaurants, 5 kilopascal. So, pag dining room and restaurants, for example, you are designing a hotel structure, then you have to apply here 5 kilopascal. Okay? Kung hindi siya eksakto, then you have to draw non-slab here, non-slab, and then you apply the loadings. But be careful, you should apply same concept as I did here. Para hindi siya, para hindi madoble yung loadings nyo. Pag nadoble yung loadings, it's gonna be a big problem, especially kapag you're designing high-rise story building. Kasi madodoble yung loads, depende sa typical building na ginagawa nyo. So, napakalaking load yon. So, you should be careful in applying loads. Then let's go back to our case, which is a residential building. We don't have hallways. Sorry. I mean, pagdating sa NSCP, pag kino-consider natin tong saan ba yung ating category? Residential, we only consider, for now, we're going to consider the basic floor area of 1.9 or 2 kilopascal. So I considered here 2 kilopascal. It depends on you if you want to be exact. 1.9 kilopascal. So after that, I think this is just story 3. Yeah, story 3. So sa story 3 lang tayo, 2 kilopascal. Let's apply on story 1 as well. Assign. Paano ko ginawa? I selected all. Okay? Select nyo lang lahat. The good thing about selecting all is beams and columns are not slabs. Basically, it's not shell areas. Okay? So, hindi sila ma-apply ng load. So, safe tayo dyan. So, kung i-select nyo lahat, then assign shell loads here, and then click this uniform, and then put it 2.5, but be careful of this. You should set this to live loads. And then always replace existing loads para kung papalit ka ng loads, papalitan yung previous loadings na in-apply nyo. Okay? Then click apply. Oh, why 2.5? For example, nagkamali ka. Palitan mo siya ng 2.0. Then just click this icon over here. But there's no selected. So ilagay mo lang yung icon mo doon. Select mo siya ulit. Then balik mo. Apply. Okay, 2 kilopascal. Pwede mong hindi i-close yan. For example, na-apply mo siya sa anong story to? Story 1. Then you go to story 2. Pwede mo rin i-select lahat. Okay? From bilisan. Apply. Sa taas, it's story 3. Sometimes, nag-vary din yung roof deck natin. Iba din yung intensity ng loadings doon. Sometimes. Okay? But for now, we're going to assume that all basic floor area has a live load of 2.0 kilopascal. Pag okay na, meron na tayong live load, meron na tayong superimposed load, we can show it in 3D. Yes, yan. Natin floor live loads. Next is the wind load and the seismic load. You already specified. Automatic na yan na pupunta na sa building natin. Once you specify this, that's the good thing about Etabs.